Okay, so we've got to keep an eye out in questions that talk about the number of cells or the population or something, where the rate of change in the number of cells is proportional to the number of cells, or dt is proportional to p, something like that. Keep an eye out for the words, and then we're going to write that. So this question is asking us to find the function that describes the number of cells after any time t. And we're given that after 2 minutes there's 1,000 cells, and after 4 minutes there's 2,000 cells, something like that. Anyway, so we can't just go straight to that. We want to state, it's probably not going to be written like that in the question, is proportional to n. Then we're going to go, therefore dn dt is equal to kn, and then just a broad reaching statement that therefore the number of cells is equal to n0, which is the number of initial cells, multiplied by e to the kt, where k is a constant and t is time. So this is going to be the function that we're looking for, and we've got these two unknowns being the original population and the constant. Clearly that's taken up all of my board, so I'm going to rub that out. So we know we're going to get to n equals no e to the kt, and we're given these two hints. So we're going to put straight into this equation here that when n is 1,000, t is 2, and when n is 2,000, e is 4. Please do not look at the textbook. The textbook tells you to divide these as a simultaneous equation, and it's not really what you want to be doing. Here, I'm going to work sideways because I'm out of room down here. See this NO? It's equal to 1,000 on e to the 2k. And this one, NO, is equal to 2,000 on e to the 4k. Once we get these two here from our equation 1 and 2, wow, equation 1 and 2, that didn't get any neater, by the way. We're going to say that these NOs are the same NOs, therefore now, although the textbook comes to the same answer, it lulls you into the false sense that you can divide these equations anytime you like, and you can't. It happens to work here, but as soon as those equations get more complicated, yeah, it doesn't work out. So please use substitution as your valid technique there. Then I'm going to get multiplied by e to the 4k, then divide by 1,000, and you can see that's going to equal 2, can't you? And we're dividing like bases here, so we're going to get e to the 2k equals 2, and just so I can fit it all in, I'm going to get e to the 2k equals 2. Okay, then I'm going to log both sides. That 2k comes down the front, and log to base e of e is just 1, so I'm getting a k equals log 2 on 2. Okay, so there's our k. Once we've got our k, we can then go back here to find our n0, or our initial population. So n0 equals, sometimes the book here will put that into a decimal function, but ideally you want to keep it in exact form if you can. If there's any chance you can keep it like that, because you just don't know what's going to pop up over here. So 1000 over e to the 2 times a half log 2. So 2 times a half is 1, so it's e to the log 2. Now, this is hard to explain, but just as when you square a square root, it undoes each other, the e and the logarithm actually undo each other. So that e and the log cancel out, and all we're left with is the 2. 1000 on 2 is just 500. So that 500, and I know it's a bit of a mess, n equals, that's our n0. So our function nt is going to equal 500 e to the k t. So that's our resulting function. Then clearly the question might go on to say, well, what's the population when t is 4? Or we might say, how long does it take? So we're finding t, the population is 10,000, and we're just putting into that equation and working it out from there using our logs or our calculator. So there's a couple of things in here. Make sure you start off with the proportion, get our two equations, solve our simultaneous equations, try and keep exact if you can. If you can't, just use your calculator because it will still come out. And one step at a time.